Hi everyone, I'm Hao Nok Yi. Today I'm going to present about the recycling of polymers. So what is recycling of polymers? So because now we have many pollutions problem like white pollutions, like you can see the trending video from YouTube that the turtles have the plastic straw in its nose, right? So recycling of polymers is very important. It is an activities able to recover metal or energy from post-consumer plastics. In simple words, we recycle these plastics into something useful or we degrade it into something less harmful. Okay, so the recycling of polymer involves certain steps. First, sorting; the second, thermomechanical degradation; the third, molten processing; the fourth, additive and fillers. After that, mixing and compatibilization. Next, new chemical process development, and in the end, pyrolysis. So after that, I'm going to explain it one by one lah. So first, sorting of polymers. So in sorting of polymers, we need to sort the polymers according to their size, according to their type. For example, there are a lot of type of polymers like PVCs or something like polypropylene, like polyester, polyamide. So we need to sort it on size and material. Besides sorting the polymers, depends on its type, we also need to eliminate foreign materials, such as, because normally the plastics material sometimes it appears on some packaging, so it will maybe have some paper stick to it, right? So we also need to eliminate the foreign materials such as metal or glass. Then after that, thermomechanical degradation. So the from the thermomechanical degradation, these two words we know is something that we use thermal to degrade the polymers, or we use something like mechanical to degrade the plastics. So degradation mechanically induced thermal process during melting process at high temperature. So it's something like we degrade it mechanically, but during this degradation it induces a lot of heat energy that will somehow melt the polymers. This process has to be done in an oxygen deficient atmosphere because our polymers normally are hydrocarbons, and hydrocarbons are something highly flammable. So that the polymers will not burn into other things like carbon monoxide. So we need to done this in an oxygen deficient atmosphere. So next, the molten processing. Okay, so after that, the polymers, we can melt it and the polymer will deform extensively. After that, then it will cool, and after that we cool it rapidly. So the shearing process during the heating and cooling will cause the molecules to take up an oriented or deformed shape, and the fast cooling leads in the deformed shape being froze in the product. So it's something like the heat treatments. We heat up the polymer and cool down it again to let it have some orientation or structure in the molecules. So after that, we will add some additive and fillers. So the additive and fillers we add are something like stabilizer to prevent the environmental effects that will cause the polymer to turn into something. For example, a stabilizer. We add stabilizer so that it does not chemically change. So stabilizer can prevent the polymers from degrading by UVs, by heat, and by light. So plasticizer, because we want to recycle it and become a new plastic, so we need to let it have some plastics properties. So plasticizer can improve its plasticity and flexibility. Next, lubricants. Lubricants will let the final product become more smooth on its surface. And after that, flame retardants, because polymer, like just now I said, has a lot of hydrocarbons. Yeah, so it's something something highly flammable. So flame retardants will increase ignition resistance, and it will decrease if its if the plastic has burned, it will decrease the smoke release, decrease the amount of smoke release. After that, mixing and compatibilization. It increases the mechanical strength of heterogeneous polymer by polymer blend by strong adhesion of dispersed particles. So heterogeneous means what? Means two different types of polymers. So it can let two different types of polymers blend together to become something better. After that, new chemical process development. So this development focus on the development, scale up and optimization of chemical synthetic rock, leading to a safe, reproducible and economical chemical manufacturing process. So it's something like it focus on the manufacturing process too, and the development and the safety that during the process of this recycling of polymers. So after that, pyrolysis, after adding these kinds of things, after doing this kind of development, at the end with pyrolysis, we break down the long polymer chain with heat. Then after that, it becomes a new polymer when it cool down. So when it becomes a new polymer, then we successfully recycle an old polymer and unused polymer to a new polymer that can use again. So yes, that's all from my presentation. Thank you.